This is iCircuit. iCircuit is an electronics simulation platform. It's incredibly easy to use because everything's drag and drop, connecting together in a kind of object-oriented programming. Behind the bells and whistles and pretty graphics of this application is an algorithm known as SPICE, which was invented by engineers, programmers, and electrical engineers to simulate circuitry. And so this is a front-end interface to a very, very powerful simulation. The reason why we use iCircuit is that the math that would be necessary to solve these problems on paper is extraordinarily complicated. And so iCircuit's going to do us a big favor in helping us to get answers to our questions and design new circuits. Every version of the iCircuit software that runs on different platforms looks a bit different. Here, I'm using the iPad version to do this demonstration because at least several of you are using it on an iPad. If you've purchased iCircuit for yourself and are running it on a different platform, on a PC platform, or on an Android device, or even on a Mac, you'll find that the menus look different. Even if the menus and their positions are different and the items are organized in a different way, it's a slightly different functionality. Everything works appropriately. So a lot of times you're just going to have to, if you're using a different platform than this one, you're going to have to use your instincts to figure out how to do things. For me, when I'm doing iCircuit, I do it on my iMac. And on my iMac, the menu for inserting components is not along the bottom, as you see here on the iPad, but it's instead along the top. And so even as I make this video, it's going to take a little bit of careful consideration for me to figure out how to do things. But I want to build some circuits. That's the whole point of doing this. And you see along the bottom, I have this wonderful collection of items that I can add. And it turns out that everything that we will learn about in this course is available to me along the bottom to slip into the simulation and find out how things work. It's very, and I hear they're all displayed to me all at once, which it may not, is a little bit dizzying to see all these things at once. So I can select them over here on the left, the library filter by category. I can look at just the sources of potential difference, things that generate analog signal, digital items, and silicon items like diodes and LEDs. So I have all of the items that I could ever want here. Now that I've selected the filter there, I deselected. Okay, so now I have everything that I could ask for, including, well, look at that, including an Arduino, first thing on the list there. Pretty sophisticated stuff. But in order to do some circuitry, the first thing I'm going to want is a DC source of some voltage. So I'll take this battery here and drag it over here out into the field and drop it. You'll notice that there's a grid here, and the items snap to a grid. There are various options for turning the grid snapping on and off. And by the way, I'm doing this in blackout mode. I like to run all of my apps in dark mode or blackout mode or whatever it's called. I like the high contrast. If you're using this in its default mode, the background is very likely white. You'll find it in the settings. You can change that. So here I have a 5-volt battery, and that's how I can get some potential difference to create a circuit. I could also use a 5-volt rail here in order to get some potential difference. Or I could use an AC source that creates me a signal that oscillates like a sine wave. You can see in the animation there, it's already blinking as the voltage sweeps back and forth between positive 5 and negative 5 volts. So I have all these different ways of creating voltage in iCircuit. Well, what if I don't want 5 volts? What if I want a value greater than 5 volts? Well, what I do is I click on this item to select it, and if I click and hold, a menu pops up that says voltage 5 here, and I can adjust that menu either by using the keyboard and simply changing it to 10, or by using this slider that appears here. So if I go and hit that to 10 volts, and then now my supply is, or my, not my supply, my voltage source, my voltage rail is 10 volts. So I'm going to use that 10 volts in order to make a circuit. And so I don't need this, for the moment, I don't need this power supply. So I'm going to move this power supply over here. I'm going to use it later. And this one I absolutely don't need. So what I'm going to do is go down here. You see along the bottom I have a trash can. So I select the trash can, and now my finger becomes a deleting device. So if I click on that 5 volts, it vanishes. I've deleted it. I have to be careful to turn the delete off again and go back into edit mode, because if I'm just going to go around now crazy deleting things. So I'm going to take this 10 volt rail that I started with here, and I'm going to hold on it, and I'm going to convert it, or change its value, back to 5 volts. The reason why is because I'm going to set up a circuit with an LED just in order to make a thing light up. And so 5 volts is appropriate for that. So I'm going to grab the next thing that I want, which is I'm going to move the position of this over. I can drag that and move it. The next thing that I want for my circuit is going to be a switch. So I'm going to go to analog, because the switch is an analog device, and go along here. I see I have a lot of different switches available to me. I'm going to grab a switch and drop it down here. But the funny thing is, my switch now is pointing in the wrong direction. If I click on it and grab it by the end, I can change its orientation in space. And I like that very much. So that switch is open. It's not going to allow current to flow. So now going back to my analog devices, I'm going to add a resistor. Now I'm going to do something important here. I'm going to place the resistor in, but notice that I did not place it so that it connects. This is an important tip for using iCircuit to build your circuit. It's going to make your life a lot easier. If I take this 1K resistor and I hold it to the end of the switch, it will connect, but I don't want to do that. Do not, in iCircuit, connect two components directly together. It'll work, but it's a bad idea for a reason that I'll show you in just a second. I'm going to need a light emitting diode here. So I'll place in a light emitting diode. Also notice, did not connect them. And what else do I need? I need a ground. So I'm going to put a ground in there. And nothing is connected. Nothing is connected, and so what I have to do is I have to draw wires in between them. So down here I have a thing on the bottom menu that looks like a pencil here. I'm selecting it. That pencil is the wire drawing tool. And the banner at the top is encouraging me to touch and drag to draw wires. So what I'm going to do is now connect each one of these bits with a wire. It's very, very easy to do. And you say, well, now they are all connected. They would have been connected if you just stacked them one on top of each other. Ah, yes. But now that I've done it in such a way that they're all connected with wires, I can do this. I can take that resistor and move it wherever I want in the circuit. Later on, when we build things that are very complicated, you'll find things get crowded and moved around all over the place. And if all of your components are connected with wires, you can nudge a component this way or that way to make your component more compact, or make your circuit more compact or more aesthetically pleasing. If you connect them all, when you move the resistor, the switch has to move with it, and everything all has to move together. So now, I want to run my simulation, and in fact the simulation is already running. I can tell because the 5 volts is green up here. If I take this up here in the far upper right, if I click on this, I've turned the simulation off. On my Mac version, there's a play pause button in the upper left hand or upper right hand corner. Sorry, did I say upper left? Upper right. In the far upper right hand corner, there's a play pause button. Here, there's a kind of Apple slide switch. You see that when it's in the off position, my circuit diagram is entirely white, or in the case of the other alternate viewing mode, entirely black. But there's no colors associated with it. So when I run the simulation, now it's actively calculating what should be the current that flows, what is the voltage on the resistor, what is the voltage on the light emitting diode. So I'm going to turn my simulation off, because when I edit a circuit, I like to edit it with the simulation off, because sometimes my edits can really confuse the calculation, and I can even crash the app if I'm building something really sophisticated. So with the simulation turned off, I'm going to realize a thing here. This resistor is far too high for me to get the appropriate current to my LED. So what I do is I hold on this resistance, and it says 1K. I don't want 1K. I want something a little bit more appropriate for a diode, and that's 220 ohms. So I have 220 ohm resistance in here, and now I'll start the simulation. When the simulation is running, this switch becomes an active item. So I can click on the switch to select it and then click it again and the switch will close. I had a little trouble there clicking. And now with the switch closed, we see that current runs from the 5-volt rail through the switch, through the resistor, and lights up the LED. I can actually see the current flowing, and that can be a good hint when I'm trying to debug something, trying to make a circuit work. Notice that the circuit is very green at the top and not green at all at the ground. This is because the color of the wire indicates the relative voltage. Where it's very green, it's 5 volts. Where it's not colored at all, it's 0 volts. If I were to go to negative voltages appear red. So in iCircuit, green voltages are positive voltages and red voltages are negative voltages. And that's important to keep in mind. So over here I have, I'm just going to build another circuit to demonstrate to you some more features that I have. I have this 1 hertz source that I've added here. Now this source is a periodic source. It is oscillating like a sine wave. And I'd like to be able to demonstrate that to you, and so I'm going to show it to you in a really clever way. First of all, I need to give a little bit of a potential difference here. So I'm going to add a ground to my circuit, connect those, breaking my own rule. Connect those with a wire. So now this is the grounded end of the supply, and this end of the supply, the part that's glowing here, I'm doing again with the simulation running, which is very silly. I'll turn that off. This end of the supply is giving me my periodic source, my sine wave source, my alternating current source. So all I'm going to do is do something extraordinarily simple. I'm going to drop in a resistor here. Drop in a resistor. Oh, look, that wire doesn't want to cooperate. So I can take the end of that wire and connect it there like that. Oh, look, it looks terrible. It's okay because it's connected with a wire. I can move it around wherever I like. So there's 1K, and then I'm going to add in very quickly a ground, connect it with a wire, start the simulator, and this is my circuit. Notice here that the color of the wire goes from green to red to green to red to green to red, passing through uncolored. It's going positive 5 volts, negative 5 volts, positive 5 volts, negative 5 volts, because that's how this voltage source here is set. If I look at its settings, it has an amplitude of 5 volts. That's how much it goes up and down by. It has a frequency of 1 hertz. That means it runs through a full cycle once per second. And there's some other items here, DC offset. We'll get into those as we learn about it in the class. There are some tools that are available to visualize the values in a circuit. Being able to tell what the value is at a particular point is really useful. Notice, if I click on this resistor, I don't get any sort of information about what's going on there. Down here at the bottom, I have a tool here that's called the meter. And when I click it, it comes up and it tells me everything about that resistor. Notice, it tells me the current, the voltage, the resistance, the power. In our electronics class, very often you'll be asked, what is the power in the 220 ohm resistor in this circuit? And you'll be able to answer that question because you'll bring up this little meter window and you'll see the power is 45.7 milliwatts. And that'll make that very, very easy to do. But another thing that I can do, see if I can do it really quick. I'm going to turn the meter off. Another thing that I could do here is insert into this circuit. You know what I'm going to do? I'm going to delete my switch. And I'm going to insert a meter into the circuit just for fun. I know I'm not doing it properly. And I'm doing it with the simulation running because I'm crazy. And I keep placing it. It keeps deleting because I've accidentally left the delete tool on. Now, when I run the circuit now, and it is running, it says 5 volts. Why is the current not flowing? Oh, because this is in voltage mode. I want it to measure current, and there you go. So now this meter that I've put in place is showing me the current all the time. It's the same thing as if I was in the laboratory and I took a multimeter and use the multimeter to measure the current. There it is, 14.47 milliamps. It's easiest, obviously, if you want to know the voltage on the LED here, to just pop up the meter and read the voltage off 1.826 volts. But sometimes we'll call on having a meter in the circuits that we design for class. So turn the meter off now. Now, with my original circuit deleted now, I have this oscillating circuit. I want to visualize the oscillating circuit. For that purpose, my iCircuit software has what's known as an oscilloscope or a scope. What I want to know is, what does the voltage on the... I was in delete mode. Analog, let me put the resistor back. Oh, man. There's my 1K resistor back again. I was in delete mode because I just previously deleted the circuit. So, I want to know, what does the voltage on this 1K resistor look like as a function of time? So I'll select the 1K resistor, and here it's getting ready to show me current, voltage, resistance, and power. The current, voltage, and power currently read 0 because the simulation is not running. I'm going to select the voltage as a quantity that I'm interested in. And you see what happens is this scope window has now appeared. The scope window is really complicated looking. It's got all kinds of details, and we'll figure those out as we go along. But the point of the scope is the scope makes it possible for me to visualize a value that is changing in time. And our most interesting circuits are ones that change over time. Things that run at constant value are okay, but they're not the coolest things going. Notice what happens when I start the simulation. The scope window is showing the value of the voltage on the resistor as it evolves in time. I can maximize this window, and we see the voltage changing as a function of time. Along the bottom, we're given the RMS value, the P to P, which is the peak-to-peak voltage, measuring the voltage from the highest voltage to the highest positive voltage to the lowest negative voltage. Since this source is configured by me to have an amplitude of 5, then the maximum value it goes to is 5. And the minimum value it goes to is -5. So the peak to peak is 5 volts up and -5 volts down. The peak to peak is 10. The frequency is 1 hertz, and it shows me the value, which is zooming back and forth there, changing consistently. It says the minimum is -5, the maximum is 5, tells me the average value over time, which is changing. The scope makes it possible for me to view signals that are changing in time, and periodically, I'll ask you to screenshot the scope window. When I ask you to screenshot the scope window, I prefer that you do it maximized like this. What will happen sometimes is students will give me a screenshot of this whole window with the tiny little scope window in the corner. I prefer that you didn't do that. When asked to take a screenshot of the scope window, please take a screenshot of the entire scoped window. Now, iCircuit is an incredibly full-featured piece of software that can legitimately be used to design circuitry, and we'll be using it for that purpose. So it's very powerful and has all kinds of sophisticated bits to it. I encourage you to mess around with it and see what you can build. You can even go on the internet and find some circuitry that you're interested in. Maybe you have an RC car hobby that you're interested in, or maybe you have an electronics project or an idea for an electronic thing that you can add for something that you're doing in engineering class, or maybe you want to, and this, believe it or not, happens to me more often than not, you're planning an incredible Halloween costume and you want to have some LED lights or something that goes on in there. So find that circuitry on the internet and design it in iCircuit and see what you can develop. The best way to learn electronics is, well, I guess I should say, to toe the party line, the best way is to take a class in electronics. But really, I learned all of the electronics that I know from simply doing things, figuring out how it works, and going through and just practicing up. So anyway, there's iCircuit. It has a lot of features that we're going to discover and use in the future, but that is our basic